Good evening, class. It's Mrs. Albright, and tonight we are working on Module 5, lesson number 17. And our objective for today's lesson is to continue using visual models to add and subtract two fractions with the same units. That means that their denominators will be the same units, but we are also going to be including subtracting from one whole. So that's how it changes from last night's lesson. It gets a little bit more difficult. So for this first problem, we have the whole number 1, and we are subtracting 3/8. So there are a few different ways that we can approach this problem. The first thing we can do is we can just rewrite this whole number 1 as a fraction. So think in your mind, how many eighths are in one whole? The reason I'm asking about eighths is because that is the unit that this fraction is in. So I want to make this a fraction with the same units. So 1 whole is equal to 8/8. So I could just write this problem as 8/8 minus 3/8. I'm going to rewrite that. My stylus is not working so well. 8/8 minus 3/8. And since my units are now the same, I don't have to worry about converting anything. I can just say 8 minus 3 and get my final answer, which is 5/8. Now, let's see what that looks like on a number line. So I'm going to draw my number line. I'm going to start here with 0, and I am going to count up. I know that my fraction has to be at least 1 whole. So I'm going to go ahead and put my 1 whole here, and I'm also going to label that as 8/8. And I'm going to mark up my number line so that I have 8 equal parts. So I'm going to mark it in half first, break it into fourths, then break each fourth in half. So now I have my eighths marked on my number line. And since I am subtracting 3/8, what that means is I'm going to hop on my number line backwards 3 times. And that's where my answer will be. That is the difference between these two fractions. So then I can count up and say 1/8, 2/8, 3/8, 4/8. There's my fraction, which is 5/8. That's where I landed on the number line. So the difference between 5/8 and 8/8 is 3/8. All right, now we're going to start with another one. And again, this starts with 1 whole. So for this fraction, I'm going to go ahead and turn this 1 whole into 5/5. And again, I'm using fifths because in this fraction, fifths is the unit that this fraction has. So I want to make this number 1 into a fraction with the same units. So 5/5 minus 2/5. I can subtract that pretty easily in my head. 5 minus 2. I know that my answer is 3/5. If I look at this on a number line, again, I'm going to start with 0. And I'm going to end with 1, which in this case I'm going to relabel as 5/5. Break this into 5 equal parts. Since I am subtracting 2/5, that's the amount I'm taking away, I'm going to hop back on my number line, 1/5, 2/5, and then I'm going to identify the point on the fraction where this is. So I can count up from 0, 1/5, 2/5, 3/5. That is the point where my number is, which then is the answer to my problem. If that went a little fast for you, make sure you rewatch this part of the video to watch it again, because on the next slide you will be attempting this on your own. So I want you to try this problem, 1 minus 7/12. If you don't already have a piece of scratch paper, please pause the video, go get your scratch paper, work this out, and answer the quiz question. All right, now that we have practiced subtracting a fraction from 1 whole, we are going to combine what we have learned about subtracting fractions and subtracting a fraction by 1 whole. Check it out. We've got a mixed number, 1 and 1/5. So the first thing that I would do to approach this problem is to turn this into a mixed number. I'm going to look at the 1 whole and ask myself how many fifths would be in this 1 whole, and the answer is 5/5. And I'm going to combine that together with the 1/5 I already have. So this 1 and 1/5, and we're going to turn that back into an improper fraction of 6/5, and then we are going to subtract 2/5. And our final answer, 6 minus 2, is 4/5. Now let's see what that looks like with a tape diagram. Again, I'm working with the unit of fifths. So I am going to draw my tape diagram, and I'm going to break it into 5 equal parts. And because this fraction here is greater than 1 whole, I actually need to draw an entirely new whole, and again break that into 5 parts. Now this original fraction, I am starting with 1 and 5/5. So the 1 whole, I'm going to color in this entire thing. That's my 1 whole. And then I have 1/5 left over. And you can see how I got to this mixed number of 6/5. If I count these all up, I've got 1, 2, 3, 4, 5, 6/5 all together. Now I look at the next part of the problem, the part that I'm subtracting. I am subtracting 2. So I'm going to take my marker, I'm going to take away that one, and I'm going to take away that one, and I'm going to see, what do I have left over? I've got 1, 2, 3, 4/5 left over. So that's how we subtract a fraction from a mixed number, or a fraction that is greater than 1. Okay, similar problem with this one. Again, we have a mixed number, which is a fraction that's greater than 1. So this is 1 and 1/4, and we are subtracting 3/4. So I'm going to start right away with drawing the tape diagram. And since it's greater than 1, I know that I'm going to need 2 of them. And I'm going to break these into fourths. And the reason, again, that I break it into fourths is because fourths is the units that we are dealing with this problem. And I'm going to shade in based on this original number, the big number that I will be subtracting from. So this is 1 whole and 1/4. So I'm going to color in 1 whole and 1/4. Now I can count those up and see that altogether I have 1, 2, 3, 4, 5 fourths. So if I had turned this into a mixed number, that's exactly what it would be. That 1 is 4/4, and then I've got the 1/4 extra. Put those together, and I get the mixed number 5/4. I'm going to subtract 3/4, so I'm going to take away 1, 2, 3, and see that I am left over with these 2/4. So my final answer for this is 2/4. Now I also want to see what this would look like on a number line. So if I start with 0, and I think about the unit that I'm counting by fourths. So I'm just going to put tick marks until I get all the way up to this number 1 and 1/4. So I'm just going to mark 1/4, 2/4, 3/4, 4/4, which is equal to 1 whole, 5/4, 6/4. I could keep going, but I only need my 1 whole and 1/4. So this is 1 and 1/4 right here. Now I'm going to look at the next part of the equation, which is the amount I'm taking away. And I'm going to hop backwards on the number line from this large number. I'm going to hop back 1, 2, 3/4. And then I'm going to identify what is the fraction of this point where I landed. And I can count up from 0, 1/4, 2/4. So my final answer, again, I can see that on the number line, is 2/4. One more example, and again, we are going to use tape diagrams to solve this one. Here we have 1 3/8 minus 5/8. So since this is larger than 1 whole, I'm going to draw 2 tape diagrams. I'm going to break each of them into 8 equal parts. And again, the reason it is eighths is because eighths is the fractional unit that I'm working with in this problem. So because I have 1 3/8, that's what I'm going to color. I'm going to color the entire tape diagram, and then I'm going to count up 1, 2, 3 more. To put this as a mixed number, I can see that with the tape diagram, that my 1 whole is equal to 8/8, And if I combine that with the 3/8 as this original number, I actually have 8, 9, 10, 11 eighths. So this fraction I can rewrite it, or this equation I can rewrite as 11/8 minus 5/8. So since I'm subtracting 5/8 from my 11/8, I'm just going to start marking them off. 1, 2, 3, 4, 5. I subtracted them or took them away, and I'm going to count up what's left. 1, 2, 3, 4, 5, 6. So my final answer is 6/8. Now, by converting it to an improper fraction, we can also just subtract across the top. 11 minus 5 equals 6. The units that the fraction is in don't change, so that remains 8. On a number line, if I'm starting with 0, I'm working with the fractional unit of 8, so I'm just going to count up 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Here's my 1 whole, or my 8/8, 1 and 1/8, 1 and 2/8, 1 and 3/8. So I've arrived at my original number on the number line. So I can label that 1 and 3/8. Now I am subtracting 5/8. So I am going to hop backwards on the number line. 1, 2, 3, 4, 5. Since I'm taking away, I am moving backwards on the number line, or towards the left. And then all I need to do is count up to determine this point on the number line where I landed. And that is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. And you can see that that also matches the result I got up here. Again, if that went fast, re-watch it. So 3 different methods that I have demonstrated here. We either convert it to an improper fraction, make sure that the bottom units are the same, and subtract across the top. We can draw a tape diagram and physically X them out, take them away. Or we can plot it on a number line, subtract or go back the amount that we're subtracting, and determine where that point is. So lots of different ways to attempt these problems. Now it is your turn to try this on your own, so use your scratch paper, work out this problem, and give me your final answer. And the last problem for the night, 1 and 3/10 minus 7/10. Again, use your scratch paper, use any one of those 3 methods that we modeled to solve this, and give me your final answer to what the difference is between 1 and 3/10 and 7/10. Thanks so much. Remember, rewatch sections of the video if you have to in order to make sure you understand it and get these answers correct. And I will see you back in class to practice this more in the morning. Have a great night.